Two blocks, one with a mass of 40 and other with a mass of 20, are connected with a massless string. The block rests on a smooth inclined plane of 30 and 45. That looks like 45, but I've written 60 though. Respectively with the horizontal. Determine the acceleration of two blocks and the tension in the string, assuming the acceleration due to gravity is 10 meter per second square. Guys, we can start by looking at this as this is your, say, person who earns, and he is a person who not only consumes but spends as well. Why is that I'm telling this? Because the pull has a negative effect because of 40 kg. Actually, it should be the other way around. This is 45. Actually, we exactly don't know who is going to earn and who is going to spend. So I'm assuming that the block will move along the 20 kg slope. So the direction of acceleration will be so, and here the direction of acceleration will be the same. Right? There's a lot to write over here. First thing is we'll tell let's assume the block will move to the right. Okay, so the acceleration will be in this manner. Next is let A be the acceleration of block of 20 kg. Therefore, 40 kg 2 will accelerate along the length, that is along the slope. Both is along the slope. At a meter per second square. This is because of thread being massless and non-elastic. So it will pull. There's no other option, right? So now we have, say, this pulling and this spending. So we have system's mass. Okay, what is the mass of the system? 20 plus 40. So this will be equal to 60 kg. That's the system's mass. Now, the force is where the tricky part is. So for this, we need to use the angles. See, the force over here is, yes, 200 Newton. And the force over here is, correct, 400 Newton. But they are not the one who will contribute to the acceleration. Not directly, of course, they are the one, but not directly this entire amount. So which will contribute? The components of this. If I resolve it along the slope, so somewhere over here is, so that would be how much? Doesn't matter actually, 45, right? This is 45, so this entire thing will be 45, 45. And so this will be 200 cos 45. Let me erase all of this. This part will be 200 by root 2 Newton. He'll be the one who will be pulling the thing down. While over here, there is a negative effect. So this 400 Newton will be pulling the other way around. 400 by, okay, now here we have to figure out the angle. So this angle will be, so we have this is 30 degree, and we have a force like this. This is also 30. Oh no, this is what we are, okay, this is the one which we are trying to figure out. So this will be 60. So 60 and this is 400. Perpendicular is over here. No, sorry. This is the perpendicular. This is one side. And this is the diagram we are looking at. 330. This is 90. We want this angle basically. This is 90. So this has to be 60. Wait, which angle do we want? Yeah, this angle only. This is 60 basically. Why is it? If I draw a line over here, this has to be 60. Okay, sorry. This will be 400. Okay, this would be 60 and cos 60 is half. So this is basically 200. Right? Okay, so this is a bit of geometry. Let me explain this. You have a slope of 30. You have a force of 400 Newton and stuff like this. So you need to resolve it along this length. Along this length. So this is perpendicular. This has to be your hypotenuse. This is 400 Newton. So this is 30. This is 90. This has to be 60. Right? Simple. Angle sum property. If this is 60, so this will be 400 cos 60. And this length will be 400 sin 60. So anyways, we just need that. So that's that. Similarly, here you have the angles and stuff, but anyways, we don't need to bother too much because this is 45. All of these angles will be 45, 45, and so I didn't bother with that. But yeah, you guys can make a note of this. Okay, so we are looking at this particular triangle. Now, the net force of the system. Systems. Net force. So one end we have a pull off along the acceleration, that is 200 by 2. On the other end, you have the opposite pull of 200. Obviously, this is greater. The acceleration is to the left. Anyways, we'll get the negative answer. Okay, now acceleration of system is equal to the net force divided by mass of the system. This is basically 200 by 2 minus 200 divided by mass is 60. It has to pull 60 basically. Okay guys, so I think that's it. Calculating this, we'll get a negative answer. Let me do it off. So 200 divided by root 2 minus 200. This is 50 minus 58.6 divided by 60. 58.6 divided by 60 is approximately 0.98 meter per second negative. So basically, negative indicates our initial acceleration was wrong. It's the other way around. So therefore, acceleration, what is that we need to find actually? Assuming the acceleration, determine the acceleration of the two blocks. Acceleration of the blocks is 0.98 meter per second square to the left. Okay. So yeah, that's how you can start off. You don't have to think too much about what direction is the acceleration. You assume something, you do the work. If you get an acceleration of whatever it is, it will be the opposite. And you can write a small statement also. Opposite of our assumed acceleration. I guess that's it. Okay, so here again I'm using a simple system of what the system's mass is, what has to be pulled, and how much force do we have in hand. I'm just calculating that. A bit of, resolving of vectors and so on and so forth. If you use a bit of common sense, right, it's quite simple. So the one along the slope is the one which will pull. That should be the force that we are considering. And if that is the case, then it's quite simple. Force we know, mass we know, divide that, and you got the answer.